Hello and welcome to my science tutorials. This is the part 2 of the dimensional analysis WASSCE phases past question and answers. So without further ado, let's start with this example that we have. So the question says, which of the following dimensions is that of force? And this is the WASSCE June 2011 question number 1, or WASSCE June 2011 question number 1. All right, so let's have a look at the solution for this problem. So we write down our solution. Now they say, which of the following dimensions is that of force? So force can be given to us mathematically as the product of mass times acceleration. Now you know that acceleration is velocity over time, or the time rate of change in velocity. So therefore it means when we are finding the dimension for force, that will be equal to the dimension of mass multiplied by the dimension of velocity on the dimension of time. Okay, and this will be equal to the dimension for force will be equal to the dimension of mass is m multiplied by the dimension of velocity. We know that velocity is distance over time, okay, and that will give us lt minus 1. So the dimension for velocity is lt minus 1. If you watch the previous part 1 of this tutorial, you realize that velocity is distance over time, and then the distance is measured, or the dimension for distance is L, then the time is t, so it becomes LT minus 1. So here you have t at the bottom. This t here is the time over here at the bottom that we see over here. So this is equal to the mass multiplied by the LT minus 1 at the top. When we send the t at the bottom to the top, it becomes LT minus 1 again. So we have the mass multiplied by LT, here becomes minus 2. And so if we join them together, we have MLT minus 2 as the dimension for force. Okay, so our correct answer over here in this particular example is the option B, which gives us MLT minus 2. All right, so let's have a look at another example. Example number 2. It says what the dimension of power is. Okay, so we have been given the options, and this is the WASSCE June 2009 question number 3. They are asking for the dimension of power. Okay, so let's look at that solution. So power is equal to work done over the time taken or just time. So if we break down work done, we know that work is equal to force times distance. The work done in moving an object is the product of the force over the distance, and then this is over time. Okay, now to save us time, I apply the dimension over here. Okay, in the previous example we saw the dimension for force, so I will not go through again. So I will just apply the dimension over here at once. But if you don't know, you break it down like I did in the previous example, and then you get your dimensions. But I won't do that since we just saw the dimension for force. So I just apply the dimension for all of them over here, and so this is what I will get. So from here it means the dimension of power is equal to that of force we saw in the previous example is MLT minus 2 multiplied by distance, which is also L, on time, which is T. So if I look here, I have L here, so it becomes L squared. So I have ML squared T minus 2 on T. So if I send this T to the top, I have ML squared T minus 2 minus 1. This T comes to the top, it becomes minus 1. So our final answer for power, the dimension of power, will be ML squared T minus 3. So if you look through the examples, we see that option 3 gives us that answer. So our correct answer for this particular example is option C. Alright, so let's have a look at one final example for this particular tutorial. So the dimension of work are, we have option A, ml square t minus 2, B, ml t minus 1, C, mt raised to the power minus 2, and then D, ml raised to the power minus 2, t raised to the power minus 2. This is the WASSCE November 2009 question number 1. Alright, so let's have a look at the solution to this problem. So the dimensions for work, okay, we already saw this, but let me do this again. So for work, okay, or work done, we know work is equal to force multiplied by distance. And then again, I know that force is mass times acceleration multiplied by distance. Okay, and then again, if you know that of acceleration, which is LT minus 2, you can proceed from here. If you don't, you can still further break it down as mass. Then acceleration is what? Velocity over time. Then multiplied by distance. Now, as at this point, you should know that the velocity, the dimension for velocity is LT minus 1. So you should be able to apply it straight ahead from here. So I will not break it further down. I'll just continue from here and apply the dimension to all of them. It means the dimension of mass multiplied by the dimension of velocity on the dimension of time, then multiplied by the dimension of distance. Okay, so this will be equal to the dimension of work will be equal to m for mass multiplied by LT minus 1 for velocity, then on time multiplied by the distance, which is also another L. So I have here, if I send the t at the bottom to the top, it becomes minus 1. So I have here m multiplied by LT minus 2 because I send the t at the bottom to the top multiplied by another L. So finally I have here m, the L, I have 2L here, power 1 plus 1. Then the t here will have minus 2. So my final answer is ml squared t minus 2. So this becomes the dimension for work. So if we look at that, we see that option 1 gives us that answer. So the dimension for work is ml squared t minus 2. So option A is the right answer. So thank you so much for watching the part 2 of this particular WASSCE physics past questions and answer on dimensional analysis. So thank you once again, and I'll see you in the next video. Bye bye.